Okay, so we're going to take just a couple of notes before you start your little virtual lab. That way you kind of understand what you're doing. So we started last week the lesson on thermochemistry, which is basically just talking about heat transfer, right? And how energy transfers between different objects. We talked about like specific heat, how some materials can transfer heat easier than others, like metal, right, can transfer heat easier than plastic. That's why it feels cold, because it's actually pulling that heat from your fingertips easier than the plastic can. So what we're doing today is talking about this term calorimetry. So this is like a lab technique that we're going to do a little virtual lab on. And it's basically the process of measuring the amount of heat that's transferred during some type of chemical reaction. Okay, so it's either heat that's being released or heat that's being absorbed in that chemical reaction. So let's review just a couple terms real quick before we get into the specifics of calorimetry. Remember, temperature is just a measure of kinetic energy of particles, right? So the higher the kinetic energy, the higher the temperature, right? Heat, okay, is really just energy transfer between samples. Okay, if something's getting hot, right, that means that it's energy is transferring to that substance. The kinetic energy is increasing, therefore temperature is increasing. Okay, so they're all kind of related to each other. So just like if you think about let me think of how to draw, like the coffee cup, right? The coffee cup, the heat is going from what's hot to what's cold, which is your hand. So it's moving out of the coffee into your hands. Okay, the energy is, so if the energy is moving, right, moving whichever direction it is, that means that the kinetic energy, right, is increasing. And then that means the temperature is also increasing. So that's why remember, your hands feel warm, because the energy is moving from the coffee to your hands. Remember, heat's moving towards you, temperature's increasing, kinetic energy is increasing. Okay, so they're all kind of related to each other. So when we're actually doing a calorimetry lab, what we're doing, this whole device here, this picture that you see, we call it a calorimeter. Okay, and we're just measuring how much energy, okay, is transferred from some type of food, okay, and how that energy is transferred to the water. Basically, that's all we're doing, okay? And since an easy way to measure energy, we measure heat energy, right? Because we can measure that by looking at the temperature. So this makes it kind of an easy way to see how much energy is actually being transferred or moved or released from this chemical reaction. Okay, so what you're actually going to do in your simulation is you're going to have some different types of food. And I'm going to post a separate video just kind of quickly walking through the simulation. But you're going to have a couple of different types of food. Okay, and we would normally do this in the lab. So this is a real lab that we do. You kind of set the food on this little cork apparatus. It's just kind of to hover the food in the air. And then you have this beaker of water that kind of sits right above it. And then you would have some kind like a thermometer going in here. Okay, so this can be like our thermometer. I don't know why it's not on the picture. Okay, so we have a thermometer. So what we're doing is we're basically measuring what's the temperature of our water at the beginning. We're going to light our food on fire. Okay, this is a chemical reaction is taking place, and every type of food only has a certain amount of energy, okay, that can be transferred. So think about like some foods are better for you, right? Some foods provide more energy for you, whereas some foods are just junk food, right? They're just empty, what they call empty calories. They're mostly just sugar. It's not an actual form of energy that you're getting. So what we're doing is this way, any energy that's contained inside this food is, well, while it's burning, it's actually going to transfer into our water. Okay, so when we see that energy transfer, we're going to see some type of temperature increase in our water. Okay, so the bigger the temp increase, right, the more energy that's being transferred. So that means the more energy that's in the food. Okay. So this is basically just what I just said. So we're going to use our water. That's going to kind of pull that energy from the food. Okay. One term, I've already talked about that. Here we go. So we'll do this little sample problem real quick. So we have an actual formula that we can use to actually calculate how much energy is being transferred. So you're going to do this in the lab. You're going to collect some data, and then you're going to plug it into a formula here, and actually see how much energy can we get from that item of food, okay, from that Cheeto or from that piece of bread or whatever it is that you're going to eat. So this is a quick little sample problem. Let me show you how we plug this in. Okay, so for example, in our lab, let's say we burn a potato chip. Okay, and we start off and our potato chip has a mass of 0.67 grams. Okay, and we're using 50 grams of water. And then we have this term called specific heat. Okay, remember we've talked about specific heat. This is basically just the ability of the water to transfer energy, basically. Let's see, I think I have the definition. No, I don't. That's okay. Every material, every item, every substance has its own specific heat. And it basically just correlates to how the energy is being transferred. Okay, so don't worry too much about the actual definition. Just know that we're going to plug it in to our formula here. And it's always specific to whatever substance you're talking about. Okay, so you're going to always be given this. It's like a constant. So we're given this here. Okay, we're given our temperature. We start at 21.5 and we rise, right? We've heated up our water with energy to 24.2. Okay, so we were trying to figure out how many joules, how much energy was in our potato chips. So I have my formula. Okay. So Q, that's what we're looking for. Okay, the mass, this is always, this says mass of water. This is always what you're actually measuring the temperature of. So since I'm measuring the temperature of my water, I'm going to use the mass of water. So that would be 50 grams. If one sample problem that I have in your notes that we'll do is talking about measuring copper. So if I'm measuring the temperature of copper, then I would use the specific heat of copper. Okay, so I have my specific heat. That's just my number that I'm given, 4.184. Okay, and then delta T, this is my temperature change. Okay, so if I'm going to find my delta T, that means I'm going to take my two temperatures. I'm just going to subtract them. And you just want a positive number. We just ignore the negative because we know that we're talking about an increase. So I know that my temperature increased basically by 2.7 degrees. Okay. So now all I have to do is just multiply out all my numbers. So 50 so I end up with 564.8 joules. Okay, so this is how many joules were in our food, in our Cheetah or potato chip. Okay, so all I did was plug it in. So let's look at, so in this case, in this formula, we measured the energy in joules, which doesn't really mean a whole lot to us. But we can use this little conversion here, and we can actually convert joules to calories. Okay, so what we're used to seeing is this term calorie. Okay, so what actually is a calorie? I have a video that it's in your notes at the end after the practice problems, and it has like a question, what is a calorie? And then it says you could watch it's a little 3-minute video. And it just kind of explains like, what does this term really mean? Like when we're talking about different types of food, you know, if something has 100 calories versus 600 calories, what does that really mean? So a calorie in general is just the energy needed to raise temperature of 1 kilogram of water, 1 degree Celsius. Okay, so basically we're talking about energy that's being transferred. Basically this is kind of the gist. The more calories, the more energy that's provided by that food. Okay, so everybody's body's different. Everybody's metabolism is different. If you exercise a lot or play a sport or you're very active, right, you probably eat more in a day because you burn a lot more energy. You need to replace the energy that you eat. That's why when they say, like, if you lead a very sedentary lifestyle, if you sit a lot, if you're not exercising, if you're eating a lot of calories, right, you're getting too much energy. And so your body has to do something with that energy if you're not burning it. So that's how it gets converted into fat, okay, which is just stored energy. So you actually probably have been thinking about energy and calories and food before. We're just going to kind of give it some specific terms and kind of talk about it more in a chemistry way here, okay? So let's do just like 1 or 2 other little practice problems just so we're comfortable with this, because you will have to do this in the lab. So again, we have our formula, Q equals MC delta T. Okay, so number 1, right, we're looking for how much energy. So our energy is always Q, right? And then so our next thing is mass, M. Remember, we're always looking at the mass of the substance that we're measuring the temperature of. So if you want to think like both of those are in the equation, okay, so that's what we're looking at. So this says 5 grams of copper. So that's my mass, okay? And it says it was heated from 20 to 80. So what's my delta T? I have 80 minus 20, so that's really 60. Okay, that's my delta T. And then it tells me my specific heat is 0.385. 0.385. So I'm just going to plug that in for my C. Okay, that's always going to be given to you some way in the problem. Okay, you don't have to know those or anything. So now all we're going to do is just multiply it in our calculator. And we end up with 115.5, and it's always joules is our unit. Okay, joules of energy. Okay, let's do one more. How much heat is absorbed by 20 grams of granite when the temperature changes from 10 to 29? Okay, so again, Q equals MC delta T. Okay, my mass is 20 grams. My specific heat is given to me, 0.790. And then my delta T, right, I'm just subtracting these two here. 10, what's the difference between 10 and 29? So I get 19. So I'm just multiplying. If my calculator would. So I get 300.2 joules, okay? So, and you can do number 3 if you want to. You just plug it in exactly the same way that we've been doing it, okay? So hopefully this formula made a little bit of sense, because you'll have to do that in the lab when you get there. And like I said, I'm going to post a second video of just kind of introducing the simulation to you so you don't spend so much time trying to figure out. It's pretty basic, and it's not very long, but it does talk to you a little bit, and so that kind of can make it seem confusing. So look out for that second video, and if you have any questions, just feel free to email.